Hello, I'm Mr. Bob, and welcome to my Algebra 1 review series. This video covers Chapter 3, Section 3, titled Solving Inequalities Using Multiplication and Division. By the end of this video, you will have reviewed methods for using multiplication and division for solving inequalities. The solutions reviewed will take the form of and reinforce your knowledge regarding the multiplication and subtraction property of inequality. Finally, you will review skills for solving real-world inequalities. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find the video helpful. It'd be very helpful. Thank you very much. Okay, objective 1. Using multiplication to solve inequalities. You can multiply each side of an inequality by the same number, just as you did with equations. When you multiply each side of an inequality by a positive number, right here, when you multiply by a positive number, right there, positive number, the direction of the inequality symbol, there it is, stays the same. When you multiply each side by a negative number, the direction of the inequality reverses. Okay, so, and that goes for multiplication and division. So here, let's look at it. The multiplication property of inequality for c greater than 0. For every real number a, b, and for c greater than 0, if a is greater than b, then a times c is greater than b times c. If a is less than b, then a times c is less than b times c. And here's an example. 4 is greater than negative 1. So 4 times 5 is greater than negative 1 times 5. And here we can look at the other. Negative 6 is less than 3. So negative 6 times 5, which is negative 30, is less than 15. And yes, it is. This property is also true for the greater than or equal and less than and equal. Here they've just used the greater than or less than, but it's also the equal also symbol. You can use the multiplication property of inequality to solve inequalities that involve division. So multiplication property of inequality for c less than 0. This is now c is less than 0. For every real number a and b for c less than 0, if a is greater than, right here, a is greater than b, then a times c is less than b times c. Now remember, c is negative. So when you have a negative, when you're multiplying by a negative, you switch, see this, you switch the inequality symbol. So if a is less than b, then a times c is greater than b times c. It just switched. It went from less than to greater than because you're multiplying the c is less than 0. Example here, 4 is greater than negative 1. So 4 times negative 2, which is negative 8, is less than negative 1 times negative 2, which is 2. That's true. Negative 6 is less than 3, so negative 6 times negative 2, which is 12, is greater than, see how it switched to positive now, greater than negative 6. And these are all true. This property is also true for your greater than or equal and your less than or equal. Example 1, multiplying by a positive number. Let's look at x divided by 2, or x halves, is less than negative 1. They want us to graph and check your solution. So x halves is less than negative 1. So remember, we're multiplying by a positive number. So in order to get the x by itself on the left-hand side, or at least remove the division, the part of the division, the divide by 2, we're going to undo that division. And you undo that by multiplying, right? Multiplying by, and the 2 we're going to multiply because this 2 is positive. We're going to be multiplying by a positive 2 on both sides using the multiplication property of inequality. Okay, and we do negative 2 on times x divided by 2, they're going to cancel. And 2 times negative 1, we now have x is less than negative 2. Notice that there's a negative sign in here, but we didn't cross the boundary from the one side to the other. That's the key. So the x is still less than negative 2. So, and if we graph that, here's the x, x is less than negative 2. Here's our negative 2 on our line. There's a circle around the negative 2, which means you don't include it. It says it's just less than negative 2. It doesn't say it's equal to negative 2. So we put an open circle on the negative 2, and x is less than the negative 2. So that means everything that is to the left, everything going this direction forever is the solution to this inequality. You can check it. We can say x divided by 2 is less than 1. That's our original inequality. So we can take the answer, negative 2, and we can say, is negative 2 divided by 2, is that equal to negative 1? And the answer is yes, negative 1 is equal to negative 1. And then we can go following the line, which is, how about 3, negative 3? Put negative 3 in here because we chose now, excuse me, negative 3. Negative 3 divided by 2, is that less than negative 1? So we're substituting a negative 3. And the answer again is yes. Negative 3 halves is less than negative 2 halves, if you will, or negative 1. Okay? Okay, example 1, check your understanding. Solve each inequality and check your solution. Okay, so let's go ahead and do it. You've got the problems here. There's 3 problems. Go ahead and pause the video and work them, and we'll come on back and we'll do them together. Okay, I'm assuming you've done that. So let's give these a look, okay? So the first thing I'm going to do is I'm going to rewrite the inequality. We got b divided by 4 is greater than 1/2. So to solve this inequality, we have to get the b by itself. We're going to do that by multiplying both sides by 4. So we have 4 times b over 4 is greater than 1/2 times 4. And that's the the 4's will cancel, give us a b greater than 4 divided by 2 is 2. The solution then is b is greater than 2. So if we had a number line and we had 2 right here, we're going to put a circle right around that, and then it's going to be everything here. B is greater than 2, not including 2. So now that we have that, we can substitute 2 in to the original. So we have 2 divided by 4. Is that equal to? First, I like to check the equal to. If it's equal to, then we know that the solution is correct at this point. And now we just have to say, well, yes, but it has to be greater than. So in that case, you can, if it was an equation, we'd stop right here. Yes, it's true. But it's an inequality. So now we have to go to the next step and say, well, is it greater than? And pick a number greater than. So let's pick 3. We're going to pick 3. If you look at here, 3 is included now because it's in the line. Here's 3 on our graph down here. So now I can put 3 in here, and it'll be, is 3 divided by 4 greater than 1/2? And the answer there is yes. The 3/4 is greater than 1/2. Let's do the next one. D divided by 3 is greater than or equal to 5 divided by 6. Well, as we did in problem A, we're going to multiply now both sides by 3 using the multiplicative property of inequality to undo the division of the 3 divided into d, and we're going to multiply it out. So we're going to say 3 times d divided by 3 is greater than or equal to 5 divided by 6 times 3. And now we simplify this, we're going to get d, because the 3 is canceled, and that is greater than or equal to 5 times 3 is 15 divided by 6, which equals what? 15 divided by 6 is equal to 5 sixths. Excuse me. Sorry, jumped the gun here. 5 halves. Or I guess you could say 2 and 1/2. Okay, so it's 5 halves or 2 1/2. So there's your solution. D is equal to 2 1/2. Now, if we want to check it, we're going to do both. The equal and the greater than have to be the same. So if we do D, excuse me, I'm just going to go ahead and substitute in the solution right off the bat here. So I'm going to say 5 halves divided by 3 is greater than or equal to 5 sixths. Is that true? Well, we're going to, in order to check this, we're going to say we're going to multiply both sides by 3, right? And that's going to, what's going to happen is to be the inverse, right? So we're going to say 5 halves times 1/3 is greater than or equal to 5 6. Because here we're dividing by 3, you invert and multiply. So here we've inverted, it's 1/3. So 5 times over 2 times 3 is 5 6. And is 5 sixths, right here, 5 6, is it greater than or equal to 5 sixths? And yes, it is. 5 6 is equal to. And now if we pick a number that's greater than 5 halves, how about 3? If we say 3, substitute it in 3. If we said 3 divided by 3, is that greater than or equal to 5 6? Well, the answer is yes, because 3 divided by 3 is equal to 1. This is equal to 1. And 1 is greater than 5 6. Okay? And now the last one. Same thing. Y divided by 0.5 is less than or equal to -3. So multiply both sides by 0.5. So we'll have 0.5 times y divided by 0.5 is less than or equal to -3 times 0.5. And when we simplify, we're going to get y is less than or equal to -3 times 0.5 is going to be 1.5. Okay, so that's the solution. Now again, we can go back and put into our answer here, we can say instead of y, we're going to put in -1.5 divided by 0.5. Is that less than or equal to -3? Well, if we take and divide 1.5 by 0.5, we're going to end up with 3 because it's 3 halves, right? Divided by 1/2, it's going to be 3. So yes, 3 is equal to, -3 is less than or equal to -3. Now if we take a more, so this y, we're saying y is less than, so that means we could pick -4. Okay, so if we pick -4, we could say is -4 divided by 0.5, is that less than or equal to -3? Well, -4 divided by 0.5 is -8. Okay. And is -8 less than or equal to -3? Yes, is the answer. Both cases. Yes. Okay. Okay, example 2, multiplying by a negative number. So this time we're going to see the inequality symbol flip, right? So let's try it. The solve, -2/3 n is less than or equal to 2. So how do we solve that? Well, I rewrote the equation. We always like to rewrite the, not equation, but the inequality in this case. And notice that I've highlighted our inequality. And down here you see it's green, it means it flipped. I flipped it. So in order to undo the multiplication of the -2/3 times n, we have to multiply by the multiplicative inverse, as we like to say. So now that is negative 3 halves. You just flip it over, right? Negative 3 halves. So negative 3 halves times negative 2/3 times n is greater than or equal to 2 times negative 3 halves. Okay, because we multiply both sides by the negative 3 halves. And when we do that, the 3's cancel, the 2's cancel, and the negative signs cancel, and we're left with n is greater than or equal to what? 2, the 2's cancel on this side, and we're left with, and it was a negative, right? Negative 2/3. So the negative, it's going to be negative, so it's now it's negative 3. So x, or n rather, is greater than or equal to negative 3. Okay, so now how can we graph that? Well, I have negative 3 outlined here on this graph, and it's greater than or equal to, so the dot right here, the dot is filled in. I filled in the dot, otherwise it'd be an empty dot, a circle, and x is greater than negative 3. So x is everything in this direction forever. So that's our solution. Now let's check it. Let's see. If we have negative 2/3 n is less than or equal to 2, and we multiply to put the answer, the negative 3 in for our solution. So we have negative 3 times 3, or negative 3 on the denominator here if we want. We end up with the 3's canceling, and we end up with, and the negative signs cancel, so we end up with 2. And 2 is, well, is it equal to 2? Yes, it is. So the solution to our inequality is correct. Now let's just find out if our symbol is pointing in the right direction. So now we go back and we pick another number that is in our solution. And our solution could be here, 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 anywhere out here. It doesn't matter. We can pick any number we want. We could pick 0 if we want. But in this case, in this example, we pick negative 2. And it is one of the solutions. So we put negative 2, negative 2/3 times negative 2, is that less than or equal to 2? So we put, this is negative times negative is positive, 2 times 2 is 4. The answer here, after you simplify, is 4/3. Is 4/3 less than 2? And the answer is yes. So we have the less than, the equal to part is correct, and the less than part is correct. The symbol is facing the right direction. So there we have the solution. Okay, example 2, check your understanding. Solve each inequality and check your solution. So we have 3 problems. I'll wait for you to do them, and when you come back, we'll try them together, okay? Okay, I'm assuming you've done that and you're back. So let's give it a look here. So the first one, we're going to write the inequality, and the inequality says negative k divided by 4 is greater than 1. So in order to undo this division by 4, actually by negative 4, because we have to get the k by itself as a positive, we're going to multiply each side by negative 4. And when we do that, we're going to say negative 4 times negative k, oh no, negative 4 times negative k divided by 4 is less than 1 times negative 4. And now the negative 4's cancel, and we end up with k is less than negative 4. 1 times negative 4 is negative 4. So there's our answer. The solution, if we looked at that, we had a number line. We have put our negative 4 on the number line, and it says it's less than, so we're going to put a circle around it. Doesn't say equal. And k is everything we're going to draw on the line, right? So the k is less than. So that's everything in this direction. So what do we, now we have that. we can put our solution in and give it a try, right? So if I said that negative, what, negative 4 divided by 4 is greater than 1, or in our case, we want to say the equal part, because we're checking to make sure that the mathematics is done. You treat it like an equation at this point. And the negatives cancel. We have 4 over 4, so that's 1 is greater than or equal. It's equal to 1. And yes, it's equal to 1. Now, the other piece to this is we're going to say that negative, negative something else. Okay, let's say negative uh, 5, because we have to pick a number that's in our solution. So let's say negative 5 divided by 4 is greater than 1. And that's going to be 5/4. Is that greater than 1? And the answer is yes. So this is correct. So let's try B. Negative t is less than negative 1/2. So in order to undo the negative sign with the t, we're going to multiply both sides by negative 1. So we're going to say negative 1 times negative t is greater than, once we multiply by the negative 1, we have to change the sign, greater than negative 1/2 times negative 1. And now these negatives cancel. We end up with t is greater than a half times a half is a positive. A half times 1 is a half. So the answer is t is greater than 1/2. So let's check it. Negative t, we're going to put in our solution, which is 1/2. Okay, is less than minus 1/2. So is 1/2 less than 1/2? Or in our case, is it equal? We treat it for the first check as if it's an equation, so it's equal. And yes, you can't say less than. At this point, I'm gonna change this. I'm gonna say that we're gonna be saying is it equal to, and the answer there is yes. So now we're gonna write it again with the inequality part to make sure that our sign is correct. So now we're gonna make sure that this is correct in our solution, right? So I'm going to go back and say negative t, and negative t is, well, we want to see here, let's take a look at the number line. I'll do the same thing as I did before. We have a solution of t is greater than 1/2. Here's 1/2. And it's greater than, so there's a circle around it. Doesn't include the 1/2. And everything in the right direction is part of our solution. Because t is greater than this half. Greater than, over here on the right. Okay, so let's pick 1. 1 is greater than 1/2. So we're going to put in here, we're going to say, in this case, negative 1, because it's negative k, and I'm picking k is 1. So it's negative 1. Is that less than negative 1/2? And the answer is yes. Negative 1 is less than negative 1/2. Okay? Don't let that confuse you. This is your solution. This is the solution put into the original equation up here. This is the solution being put into the equation. This is the solution, and this is a graph of the solution. This is the checking. You put the solution values back into the inequality. Let's do C. 6 less than or equal to negative 3/5 W. So we have to get unwind the W from its negative 3/5. And you do that by multiplying by positive 3/5. So I'm going to say 3/5, excuse me, by negative 3/5, excuse me, by negative, excuse me on that. It's not negative 3/5. You multiply each side. If I get this correct, I guess I make a few mistakes here and there, don't I? 5/3, right? So it's the reciprocal. So it's negative 5/3 times 6 is greater than or equal to negative 3/5 W times negative 5/3. So this cancels this, and we're end up with the W on this side. The inequality shifted from being greater, this is being less than, now greater than. So it's a greater than or equal to. And what is it? It's 5 times 6 is 30. Negative 30 divided by 3 is negative 10. Okay, so the solution here is W, or we could switch it, but we'll just leave it like it is. Negative 10 is greater than or equal to W. So negative 10 is greater than. So that would imply what? Here's our line. Here's our negative 10. And W, 10 is greater than W. So 10 here, W must be over here because 10 is greater. Here's the greater, here's the less than, right? So this is the direction we're going. Okay? So this is the solution. Negative, it's everything less than, and it's also a dot on the negative 10 because it's equal to. So negative 10 is greater than or equal to W. So that's as far as we go, the negative 10. So put the solution in. We say 6 is less than or equal to negative 3/5 times W. And what do we say W is? Negative 10. Okay? And if we solve that and we look at it, what are we going to get? We're going to get, we'll take, um, yeah, so 3 times 10 is 30. So we have the 6 is less than or equal to, we can count this now, like the equation part. We're solving the equal part now. So we can say that 6 is less than or equal to 30, or in this case, negative times the negative is positive 30 divided by 5, which is 6. So yes, the equal part is true. Now let's check the less than part. So is 6 less than or equal? And let's pick negative 10, let's pick negative 20. Say, okay. So now we're going to say 3/5 negative 20. Oops, 20. Because 20 is part of the solution, right? Anything here to the right or left of negative 10 is a solution, so 20. Here's our 20. Uh, got a little sloppy on that because I had the 1 in there, right? Negative 20. So now let's solve that. 6, is that less than or equal to 20 or 60 divided by 5? And what is 60 divided by 5? 60 divided by 5 is, excuse me, I had to sneeze there. Anyways, it's 12 is the answer. So where are we right here? 6 is less than equal to, right here, is 6 less than or equal to 12? And the answer is yes, it is less than, not, it is less than 12, so that satisfies also our solution right there. Okay, objective 2, using division to solve inequalities. Solving inequalities using division is similar to solving inequalities using multiplication. Remember that division by 0 is undefined. So let's look at our definition of division property of inequality. For every real number, A and B, and for C greater than 0, we're talking about positive numbers that are not 0, right? If A is greater than B, then A divided by C, that positive number we're talking about, is greater than B divided by C. If A is less than B, then A divided by C is less than B divided by C. So let's look at an example. 6 is greater than 4. So 6 divided by 2, which is 3, is greater than 4 divided by 2, which is 2. How about 2 is less than 8. So 2 divided by 2, which is 1, is less than 8 divided by 2, which is 4. And that's true also. How about for every real number a and b, for C less than 0, a negative number now. If a is greater than b, then a divided by c, and don't forget c is negative now, and it can't be 0. If it's 0, it's invalid. You cannot do it. Okay, it's undefined. A divided by a negative number c is less than b divided by that negative number c. Or if a is less than b, then a divided by that non-negative number, that non-zero number, negative though, is greater than b divided by that same negative number. Let's look at an example. 6 divided by 4. So 6 divided by negative 2, which is negative 3. But if you notice, this sign here flipped. It was 6 is greater than 4. So now 6 divided by negative 2 is less than 4 divided by negative 2, which is 2. Negative 3 is less than negative 2. This way, 2 less than 8. So 2 divided by negative 2 is greater than 8 divided by negative 2. Because 2 divided by negative 2 is negative 1, and that is definitely greater than 8 divided by negative 2, which is negative 4, and negative 4 is less than negative 1. Negative 1 is a greater number. This property also applies to the greater than or equal to and less than or equal to symbols, operations. Okay, example 3, dividing to solve an inequality. Solve. Negative 5z is greater than or equal to 25. Solve and graph your solution. So we rewrite the inequality. Negative 5z is greater than or equal to 25. And right away we're going to have to divide both sides by negative 5 to get rid of the negative 5 with unravel the z times negative 5. We're going to have to divide by negative 5. And when we do that, the moment we do that, the inequality flips. It went from greater than or equal to less than. And now it's 25 times negative 1/5. And when you do that, z is now less than or equal to negative 5. And if you graph that, we're going to put it's less than or equal. So right here we have a dot on the negative 5, not an open circle. It's a dot because we're including the negative 5. And it says z is less than that number. So that means everything here to the left is a solution to that problem. So negative 10 is a solution to this inequality. Okay, example 3, check your understanding. Solve each inequality and just check your solution. So 3 problems. I'll go ahead and stop the video. When you come back, we'll try them together. Okay, we assume that you had time to look at these, and let's do them together now. So first thing, what do we always do? We always rewrite the inequality in this case, which is negative 2t is less than 8. Okay, so like solving an equation, we're just going to get the t by itself. So in order to do that, we're going to divide both sides by negative 2. Okay, and when we do that, we're going to say, I'm going to do it here, negative 2 and negative 2. But then when we do it, I'm going to draw in here, we change the direction of the inequality, right? It kind of looks funny because I have this division here, but it's the best way for me to put it in. So this is 1, so t is now greater than 8 divided by negative 2, which is negative 4. So if I say t is greater than negative 4, it's not equal. So if I say that this is negative 4, I'm going to have to put a circle around the negative 4 because it's not equal to negative 4, but it's greater than. And now t is greater than the number. So I just have to go on this number line and say that everything that's greater than that number is a solution. So that would mean in this case that 8 or 5 or whatever, right, would also be a solution. Or 0 would be a solution. Negative 4, right? So let's try it. So let's go in and put our negative 4 in to check it. It says check your solution. So I have minus 2 or negative 2 times negative 4. Okay, this is less than 8. And is that true? Less than, or since we're, the first half you do is you check for equals. Even though it's not less than or equal to, you have to treat it like an equation to get the correct solution. You're finding the number on the number line that we're comparing against. So negative times a negative is a positive. 2 times 4 is 8. So 8 is, in our case, equal to 8. Okay. So now this says here that t is greater than negative 4. So if I picked 0 or any other number, what if I picked 0? What would happen? I'd have right here negative 2 times 0. Is that less than 8? Is 0 less than 8? Yes, it is. Okay. What if I picked 4? If I put it in here, negative 2 times 4, is that less than 8? Negative 2 times 4 is negative 8, right? And is negative 8 less than 8? Yes, it is. So that's correct. How about this? Negative 3w is greater than or equal to 12. And like I said before, the first thing we do is treat it like an equation. We're going to say we have to move, get the w by itself. So we're going to divide both sides by negative 3, negative 3. And since we're dividing by negative 3, our inequality is going to change directions. Right there, change directions. And now these cancel and we get w less than or equal to 12 divided by negative 3 is negative 4. Again, I'm going to put, here's negative 4. It's less than or equal, so I'm going to put a big old dot on it. And w is less than the negative 4. So that means that w is everything here that's less than negative 4, which is negative 5, negative 10. Those are all less than negative 4. So now let's check it. So what do we do to check it? We're going to say, let's put in, first of all, we're going to put in equals, right? So if I put in negative 3 times negative 4, does that equal 12? And the answer is 4 times 3 is 12. Negative times negative is positive. So yes, 12 equals 12. Now we're going to go with the inequality sign, which is, it says it's greater. So is negative 3. Now we're going to put in, let's put in negative, let's see something. Before I put a 4 in, let's put in an 8. Let's see what happens. Okay. Negative 8. So times negative 8. Is that less than, oh wait, is that greater than 12? So what is negative times negative? It's positive. 3 times 8 is 24. Is 24 greater than 12? Yes, it is. So this is the solution. Negative 4 is the solution. Now this one's a little trickier, and I'll explain it as we do it. We're going to solve it like the equation. This is an inequality that is not equal. So we're going to have that circle we talked about. So we're going to divide each side by negative 2. Okay. And in doing so, I'm going to write it 0.6 is greater than negative 0.2 n. So now how do we get the n by itself? We have to unravel this multiplication, unwind it. So we have to divide by negative 0.2. So I'm going to say divided by negative 0.2 on both sides, divided by negative 0.2, and the inequality switches. So from greater than to less than, okay? So now when we do that, 0.6 divided by negative 0.2 is negative 3. And that negative 3 is less than n because these cancel, right? Less than n. But when you when they ask you for the solution to an inequality, they always want you to put the variable first. And in order to do this, you're going to, -3 is less than n. What does that mean? It also means that n is greater than -3. So when you flip that around, it's like multiplying and dividing, right? Because you're going to flip that symbol. So there's the solution there. N is greater than -3. So let's go ahead and put in n equals, what did it say? N is equal to -3. So here's our -3. It's not equal. We're going to put a circle around the -3. And it says here that n is greater than -3. So that means that these are all the n values here on the greater side. So let's pick a -4, or let's put -3 in first. So we have 0.6 greater than -0.2 times, what do we put in? -3. Okay, when we solve this, we get is -0.6, is that greater than, negatives cancel. Okay, so it's positive. 0.2, in the first case we're going to do is what is not even the greater than, we always want to do the equal part first to check the solution. And it says, is it equal to 0.6? And yes, negative 0.2 times -3 is -0.6. So that is yes. The solution is correct in terms of the numeric value, the equals part. Although this is not, so the solution doesn't include equaling the -3. So now let's pick a value that's in here, and we're going to go with 0 again. I like 0. So now I'm going to say, is 0.6 greater than negative, um, yes, negative 0.2 times 0. And this is 0. And is -6 greater than 0? Yes, it is. Solution. Okay, example 4, real-world problem solving here. The student council votes to buy food for a local food bank. A case of 12 jars of spaghetti sauce cost $13.75. What is the greatest number of cases of sauce the student council can buy if they use at most $216, excuse me, for the project? So first thing we're going to do is we're going to try to convert this question into something that could be written into algebra, so to speak, right? So we're going to say, what is the cost? They want to the cost of 12, a case of 12 jars, the cost per case. We know that it's $13.75. And times how many cases can they buy? We know that we want to know how many cases can they buy right here. And then it says, is at most the total cost? Because they say at most right here. They don't want to go over $216. That's the most, not a penny over. So let's put this into an equation or an inequality. How's that? 1375 times C, the number of cases, $13.75 times the number of cases, has to be less than or equal to $216. So we're going to write the inequality as what? 1375 times C is less than, because can't go over 216, or it could be exactly equal to 216, less than or equal to 216. So in order to unwind the multiplication on the value C, the number of cases, we're going to divide each side by 1375. Okay, there's no adding or subtract, no negative or positive, no negative numbers for sure. So we don't switch the symbol. So we're just going to divide both sides. And when we do that, we get that C is less than or equal to 15.71. That's exactly, it has to be less than that amount. Okay. So the student council, and it has to be an even case. They're not buying partial cases, right? This is real world. When you're in the real world, you don't get, you know, part cases or half a car or half an orange kind of a thing, right? So the student council can purchase at most 15 cases of spaghetti sauce. Okay, example 4, check your understanding. Solve. Students in the school band are selling calendars. They earn 40 cents on each calendar they sell. Their goal is to earn more than $327. Write and solve an inequality to find the fewest number of calendars they can sell and still reach their goal. So in essence, we want to know how many calendars do they have to sell to get to their goal. So pause the video and give it a try. When you come back, we'll work on it together. Okay, now that you're back, let's go ahead and take a look at this. Students in the school band are selling calendars. They earn 40 cents on each calendar they sell. Their goal is to earn more than $327. Write and solve an inequality to find the fewest number of calendars they can sell and still reach their goal. So in order to, let's start by writing this somehow into words that can be converted into an equation. So what do we know? We know that we're paying or earning $4 or 4 cents, excuse me, 40 cents per calendar, and we need to know how many calendars do they have to sell. So it's times how many calendars sold, and that has to be more than the goal. And the goal is $327. So we're going to let C equal the number of calendars they have to sell or sold, I guess. And when we do that, we're going to get 0.4C has got to be greater than $327 because what did they say? They wanted the fewest number that earned their goal, but they want to earn more than, right here, they want to earn more than the 327. So down here, when we write this, it's the calendar sold, right? It's 0.4C is greater than 327 because they didn't want equal, they want greater than. So it's greater than. So what do we get? That's writing the equation out right here. So we're going to know what? We're going to undo the multiplication, which is the multiplication of the 0.4 times the c. And in doing that, we're going to multiply, or divide rather, excuse me, each side by 0.4. And that's what we're doing here is dividing each side by 0.4. And when we do that, the 0.4s cancel on the left-hand side, and you get 327 divided by 0.4. And when you do that, you get C is greater than 818 calendars. Okay, they have to sell more than 818 calendars. Okay, and then we check it, we put 0.4, 818, you get 327.2 $327.20. Okay, so they could sell greater than or equal to 818 and make their goal. So the band members must sell 818 calendars. Okay, thanks for sticking with us.